I will be doing Midterm 3, Problem 1. It's titled, I Get No Kick from a Plane. And it states, U-Screwed Airlines equipped all of their planes with 4 engines. Company officials are trying to keep secret the fact that on any given flight, each engine will fail, independently of the others, with probability 0.4, and the plane will crash if more than half of the engines fail. Sub-question A is asking, what is the probability that a particular plane will crash? So the first thing that we should do is make a tree diagram of the probabilities. I labeled F for failure of the engine and NF for the engine not failing. So we already know that the probability of an engine failing is 0.4. So that means we can subtract that from 1, which gives us the probability that the engine will not fail. So in this case, if the probability of an engine failing is 0.4, then our probability of an engine not failing is 0.6. Now, as we move on to the next section, it states that each engine will fail independently of the others. What that means is that each engine is independent, and they have an equal chance, they have an equal probability of failing, just as like the first as the engine before it. So each branch off from an F and NF represents one engine. So and they said that there are 4 engines total. So there are 4 stages to that tree diagram. Now, and so since they are independent, each F will represent 0. So it keeps the probability 0.4 and not failing 0.6. So since we've made our diagram and we can visually see what the probability is for either all 4 engines failing, 3 engines failing, we can make a table now. We can make a table of exactly how many engines the probability of how many engines would fail. So in this table, the values are 0, 1, 2, 3, and 4, representing if one engine if no engine fails, 1 engine fails, 2 engine fails, and the probabilities are right there. So 0.6 times 0.6 to the 4th would represent that all 4 engines will not fail. So that comes out to 0.1296. The second one, the probability that 1 engine would fail is 0.3456. The probability that 2 engines would fail is 0.345, also 0.3456. The probability of an engine 3 engines failing is 0.1536, and the probability of 4 engines failing is 0.0256. So, and as you can see, what's important is that you need to find the coefficient. And how I got my coefficient was through Pascal's triangle. So each line in the triangle represents if there's 1 value, 2 values, 3 values, 4 values, 5 values, and 6 values. If in this case we have 5 values, so the coefficients are right there, 1, 4, 6, 4, and 1. So in question A again, it's asking, what is the probability that a particular plane will crash? Well, in the problem, it also states that the plane will crash if more than half of the engines fail. So if we want to know the probability that the plane will crash, if the plane will crash, we would just need to add the probability 0.1536 and 0.0256, and we add those to get 0.1792, and the probability of the plane crashing. Oh, and we times that by 100 so that it would become a percent. So the probability of a plane crashing is equal to 0.1792 or 17.92%.